Hey all, welcome to the Unit 6 study guide video. Gonna start first with the study sheet. So you should all have a paper copy of this. Make sure to fill this out before the test. Fill this out. The key, which I'll be referring to in the video, is here. Is here. Okay, I don't know why it's doing that. There we go. Is here. And so I'll be referring to this in the video. Make sure you have this filled in. Make sure you have it on your copy. Okay. We're gonna jump over to here. Let's zoom in a little bit, and I'm gonna go through it. So again, I've already written out the answers, but I'll talk about how I got there. Do not just copy down the answers, because you won't really understand what's going on. So the first one is, okay, the New York Times conducted a nationwide poll of 1,048 random selected teenagers to estimate the proportion that have a TV in their room. They found that 692 had TVs in their room. Create a 90% confidence interval for the proportion of all teenagers who had a TV in their room, and interpret what your interval means. The parameter. So the parameter is what you're trying to discover. So we're trying to discover the proportion of all teenagers who have a TV in their room. I mean, that's in the question. It's like what you're trying to figure out. We're trying to estimate this. Confidence level is 90%. That's given to us right here. It tells us. That's a gimme, right? It tells you. Then we're going to name our procedure. You're going to get this straight from your notes. We identify that this is a proportion. It tells us proportion here. So when you go to your notes, you're going to stick to that proportion column, and it has it right at the bottom. Name of the procedure. Boom. One sample Z interval for P. Now we're on conditions. So again, now that you know your proportions, you're going to stick to that proportion column, right? So we're going to go down to conditions. I got two conditions, random and large counts. So we go ahead, we put them in here, random, large counts. Now we test them. So for random, the data must come from a random sample. So we look up above and we say, okay, we see that they were randomly selected teenagers. So I can say that yes, it does meet the requirement because the teenagers were randomly selected, as it says. For the large counts condition, we must meet these two requirements. So back to the notes. It must be that NP is greater than or equal to 10, and that n times 1 minus p is greater than or equal to 10. So when I sub in n and p, my n is 1048, my p is 0.66. How did I get my p to be 0.66? Well, it didn't tell us what the p was up here, but if you look, it does say that 692 out of 1048 had TVs in the room. So 692 divided by 1048 is in fact 0.66. So that's how I got that to be the p hat. So that's why that's going in here. So 1048 times 0.66 is 692. That is bigger than 10. 1048 times 1 minus 0.66, I got 356. That is also bigger than 10. So it meets the large count conditions because these two are true. You must have these here. They must be in the answer. Okay. All right. Moving on. Standard error. For the standard error, once again, you're going to follow this equation. So again, just you refer to your sheet, this one right here, formula for standard error for proportions. We're just going to plug it in. Where you use a p hat, you put a 0.66. So it's 0.66 times 1 minus 0.66 over 1048. That's the n. When you do that in the calculator, I got 0.015. Okay. The critical value, 1.645. How did I get that? You get it from the sheet. I know that's a 90% confidence level, so it must be a z-score of 1.645, a critical value of 1.645. Okay, so that's where that comes from. Margin of error is where you multiply that critical value times the standard error. So it's 1.645 times 0.015, and I got 0.025. Boom. Now we do the confidence interval. You're going to take that point estimate, the 0.66, that was our p hat from before, that 0.66. You take that value, you add the margin of error, you take that value, subtract the margin of error, and that's your lower bound and your upper bound. So you put those in here, 0.635, 0.685, and then we write our sentence. We can say with 90% confidence that the true proportion of teenagers with a TV in the room is between 0.635 and 0.685. Done. You want to put this in your notes. Put this sentence structure in your notes so you know what to write. I want to see it written like this. Okay? If they instead sample 2,000 teachers, would the interval be narrower or wider? It's going to be narrower, guys, because if you think about the standard error, this is our n down here. This is our sample size. So if I make that sample size 2,000, it's going to decrease this number because you're dividing by a bigger number. Okay, so it's going to make it narrower because the standard error is going to be smaller. Therefore, the margin of error is going to be smaller. Therefore, your confidence interval is going to be narrower. Okay, so I'll put that down as the y here. Increasing sample size means that n increases and the standard error will decrease in size. This means a smaller MOE and a narrower confidence interval. Okay? If they use a 99% confidence, would it be narrow or wider? Well, it would be wider because, well, think about it intuitively. If you want to be more confident, you got to cover more ground, and that's represented here by those critical values. Critical value for 90% is 1.645, but for 99% it's 2.576. That means that that MOE, the margin of error, is going to be bigger because you're multiplying by a bigger number. Okay, so that's why it's going to be wider. Higher confidence means a higher critical value and MOE. Wider confidence interval. Okay? The advertisement for medicine claims, this is number 2 now. The advertisement for medicine claims that it can provide allergy relief. A random sample of 20 people with allergies were given the medicine and asked to record how long it took for them to feel relief. The mean time was 61.3 minutes, with a standard deviation of 4.6 minutes. Construct a 95% confidence interval for the mean minutes of relief. Minutes till relief. Okay. State the parameter. Well, the parameter is, again, that's what I'm trying to figure out. And that is the average time to feel allergy relief, right? How long it took for them to feel relief. The population average time to feel allergy relief. That's what I'm trying to estimate. Confidence level is 95%. It tells me that right here, 95%. The plan. So again, you name the procedures. Go to your table. We know we're on means, right? Nothing about percentages here. We're talking about means, average values. One sample t interval for mu. So right here I wrote one sample t interval for mu. This is the Greek letter. I couldn't type it in. It's the Greek letter mu. Okay. Conditions, same as before. We go back, condition, I got random and I got normal or large sample. So here random and normal or large sample. Doesn't mean the random, it's the same as before. You go check the question. It says right here a random sample. So yes, it does meet it because the sample was random. It tells me. Is it normal? Well, for that we have a couple ways to check it. It can tell us that it is. It tells us it's normal, or the sample size is large, it's above 30, greater than or equal to 30. Nowhere in here does it say that the sample was normally distributed. It does not say in here that it was normally distributed. So it does not meet it on that way. And the sample size was actually 28, which is less than 30. So no, it does not meet the requirement. The sample size is 28, which is less than 30, so it does not meet the condition. It does not tell me that the distribution is normal. Okay? But even though it does not meet that condition, we still do the work. So in the do, I highly recommend that you take the time to find the values before you start doing the work. Our n, our sample size was 28, the standard deviation was 4.6, and the mean was 61.3. I'll show you how I got that in the question. It says 28 people, that's my n. I'm going to highlight that. Mean time, 61.3, that's my mean right there. And then 4.6 minutes standard deviation, that's my standard deviation, right? Okay, so I have my 3 values. I marked them here, n, s, and 61 in my mean, and now I plug them in. Standard error, follow the formula. It's the standard deviation divided by the square root of n. So standard deviation was 4.6, divide that by the square root of 28, you get 0.87. Degrees of freedom, df, it's right here, is n minus 1. So 28 minus 1 is 27. Okay, now we got to use a t-table. This is important, guys. Use a t-table. I got 27 degrees of freedom. So I'm going to go to 27, and my confidence level is 95. So I'm going to find the intersection of 95 and 27, and I get 2.052. So here, for a critical value, 2. Did I get that wrong? 2.052. That's a good thing I'm recording it a second time here. It's 2.052. It's going to change some answers down here below. My margin of error is 2.052 times 0.87. So let's recalculate this. 2.052 times 0.87, 1.79. Okay, well, it's a good thing I'm redoing this. So we're going to add not 2.18, 1.79 to both the the mean, and we're going to subtract it from the mean, and we will get 1.79 plus 61.3 is 63.09, and 61.3 minus 1.79 is 59.51. So the confidence interval is from 59.51 to 63.09. Okay? So conclusion. We can say with 95% confidence that the average time for the population, let's say like the population average. Let's reword this. The population average time to experience average allergy relief from this medication is between, I gotta change this, 59.51 and 63.09. Okay? The advertisement claims that the medicine gives relief in an average of 60 minutes. Based on your confidence interval, do you doubt this claim? Explain why. Well, 60 minutes is within this range. See, that's between 59 and 63. Like, it's between those two, 59.5 and 63, right? So we don't doubt. We do not doubt it because it's within our confidence interval, so it seems reasonable. If, hint on the test, the value is outside the confidence interval, so let's say it was 64, 65, we doubt it. We would doubt that. If it's inside it, we accept it, right? We don't have any reason to doubt it. But if it's outside of here, that's really kind of suspicious because we're 95% confident that it's going to be between these values. Okay, that's the test. Pretty straightforward. Make sure you come prepared. Come with the notes. Make sure you've done the delta. Okay. All right. I'll see you soon.